picture this. Right now, as you listen to these words, there might be quantum processes happening inside your brain that are fundamentally different from anything a computer could ever do. Processes so strange that they challenge everything we thought we knew about the nature of consciousness itself. What if the mystery of why you have inner experiences, why there's something it's like to be you, isn't just a puzzle for philosophers, but a window into the deepest quantum mechanics of reality? Welcome to a journey into one of the most fascinating and controversial ideas in modern science. I'm here to guide you through the mind-bending possibility that consciousness itself might emerge from quantum mechanical processes occurring in the microscopic structures of your brain. It's a theory that sounds like science fiction, yet it's being seriously investigated by Nobel laureates, neuroscientists, and quantum physicists around the world. Before we dive into this quantum rabbit hole, take a moment to settle in wherever you are. Get comfortable. You don't need to remember every detail or take notes. Just let these ideas wash over you like gentle waves, and notice how they resonate with your own sense of what it means to be conscious, to be aware, to be you. Now, what I'm about to share with you isn't just another theory about the brain. It's a radical reimagining of consciousness that could bridge the gap between the cold, mathematical world of quantum physics and the warm, subjective world of human experience. And fair warning, some of these ideas might challenge everything you thought you knew about the relationship between mind and matter. Let's start with what philosophers call the hard problem of consciousness. It's deceptively simple to state, yet it has puzzled the greatest minds for centuries. Here's the question: why do you have inner experiences at all? Think about it for a moment. Right now, you're not just processing information about these words, you're experiencing them. There's something it's like to hear my voice, to understand these concepts, to feel whatever emotions or curiosities they might stir up. You have a rich subjective inner world of colours, sounds, thoughts and feelings. But here's the puzzle. All the functions of your brain, memory, attention, decision-making, pattern recognition, could theoretically happen without any inner experience at all. You could be what philosophers call a zombie, processing information and behaving exactly as you do now, but with no inner light of consciousness illuminating your mental processes. So why isn't that the case? Why is there something it's like to be you instead of just complex biological computation happening in darkness? Traditional neuroscience has made incredible progress mapping the brain, understanding how neurons fire, how networks process information, how different regions contribute to memory and perception. Yet for all this progress, we still can't explain why any of this should feel like anything at all. It's as if we've become experts at describing the mechanics of a symphony orchestra, every instrument, every note, every timing, but we still can't explain why music exists, why it moves us, why there's something beautiful rather than just organized sound waves. This is where quantum mechanics enters our story, bringing with it possibilities so strange they seem to belong in a different universe entirely. And in a sense they do. They belong to the quantum universe, where the normal rules of everyday reality don't apply. In the quantum world, particles can exist in multiple states simultaneously until they're observed. They can be connected across vast distances through what Einstein called spooky action at a distance. And most mysteriously of all, the act of measurement or observation seems to play a fundamental role in determining physical reality. Now, for most of the 20th century, scientists assumed that quantum effects, while crucial for understanding atoms and subatomic particles, were irrelevant to biology. The brain, they reasoned, is too warm, too wet, and too noisy for delicate quantum states to survive. It's like trying to maintain a whispered conversation in the middle of a thunderstorm. But what if that assumption was wrong? What if life, including conscious life, has found ways to harness quantum mechanics, even in the chaotic environment of biological systems? As you contemplate this possibility, notice how it feels to consider that your thoughts right now might be intimately connected to the fundamental quantum fabric of reality. It's a humbling and awe-inspiring idea, isn't it? Deep inside every cell in your body, including the neurons in your brain, there exists a network of structures called microtubules. For decades, scientists viewed these as simple scaffolding, the cellular equivalent of tent poles that give cells their shape and structure. But in the early 1990s, two researchers, Nobel laureate physicist Roger Penrose and anesthesiologist Stuart Hameroff, proposed something revolutionary. What if these microtubules weren't just structural supports, but were actually sophisticated quantum computers? Picture this. Each microtubule is made up of thousands of protein subunits, called tubulins, arranged in a precise geometric pattern. These tubulins can switch between different conformational states, like tiny molecular switches, but unlike classical switches that are either on or off, quantum mechanics allows these tubulin proteins to exist in superposition states, being both on and off simultaneously. Now imagine networks of these quantum switches throughout your brain, processing information not just through the classical firing of neurons, but through quantum superposition and entanglement. The implications are staggering. According to what's called orchestrated objective reduction theory, or ORC-OR for short, consciousness emerges when these quantum processes in microtubules reach a critical threshold and undergo what Penrose calls objective reduction. This is a specific type of quantum collapse that occurs not of space-time itself. Think of because of external observation, but because of the geometry like this. Your brain might be orchestrating quantum symphonies on a scale so small that billions of quantum events could be happening in the time it takes you to blink. And somehow, from this quantum orchestra, the music of consciousness emerges. Now I know what you might be thinking. This sounds too strange to be true. How could such delicate quantum processes survive in the warm, chaotic environment of a living brain? This is where recent discoveries in quantum biology have turned our understanding upside down. It turns out that nature has been using quantum mechanics for billions of years, long before humans ever discovered it. We now know that photosynthesis, the process that powers most life on Earth, relies on quantum coherence to achieve near-perfect efficiency in energy transfer. Birds may use quantum entanglement in their eyes to navigate using Earth's magnetic field. And even the sense of smell might involve quantum tunneling effects. But perhaps most remarkably for our story, researchers have recently discovered quantum effects in the exact structures that the consciousness theory predicts: the microtubules and the tryptophan networks within them. In 2024, scientists confirmed something called superradiance in networks of tryptophan molecules, the same aromatic amino acids found abundantly in brain microtubules. Superradiance is a quantum phenomenon where molecules collectively emit light more efficiently than they would individually. It's like a quantum choir where the whole becomes greater than the sum of its parts. What makes this discovery so significant is that it demonstrates quantum coherence, surviving and even thriving in biological systems under conditions that should destroy it. These tryptophan networks could be functioning as biological quantum fiber optics, allowing information to flow through the brain at the speed of light rather than the relatively sluggish pace of neural electrical signals. As you absorb this information, take a breath and consider. What would it mean if your thoughts were traveling not just through neural networks, but through quantum channels operating faster than your neurons could ever fire? One of the most compelling pieces of evidence for quantum theories of consciousness comes from an unexpected source: anesthesia. When you go under general anesthesia, you don't just fall asleep, you lose consciousness entirely. There's no experience, no dreams, no sense of time passing. It's as if you briefly cease to exist as a conscious being. But here's the fascinating part. Anesthetics don't significantly affect the basic electrical activity of neurons. Your brain cells continue firing, processing information, maintaining vital functions. So why does consciousness disappear? Quantum theories of consciousness offer an intriguing answer. Research suggests that anesthetic drugs specifically disrupt quantum processes in microtubules. They interfere with the quantum coherence that, according to Aucour theory, is necessary for conscious experience. In one remarkable study, researchers found that when they gave rats a drug that binds to and stabilizes microtubules, the rats took significantly longer to lose consciousness when exposed to anesthetic gas. It's as if strengthening the quantum processes made consciousness more resilient to the drugs designed to eliminate it. This isn't just academic speculation. Understanding the quantum basis of anesthesia could lead to better, more precise anesthetic agents with fewer side effects. It could help us understand why some people are resistant to anesthesia, or why consciousness sometimes returns unexpectedly during surgery. More broadly, it suggests that consciousness isn't just an emergent property of neural complexity, but something that requires specific quantum mechanical processes to exist. The speed of consciousness. Here's another puzzle that quantum theories help illuminate: the remarkable speed of conscious recognition and decision-making. When you see a familiar face, you recognize it almost instantly, in a fraction of a second. When you're driving and suddenly need to swerve to avoid an obstacle, your conscious decision happens faster than many of your neurons could even fire once. Classical neural networks, for all their sophistication, operate at the speed of electrochemical signals, roughly the speed of a fast bicycle. But quantum processes in biological systems can operate at the speed of light. The super-radiant effects discovered in tryptophan networks happen in under a picosecond. These a billionth of a millis quantum networks could be processing information hundreds of millions of times faster than chemical processes alone would allow. Imagine consciousness not as a slow-building crescendo of neural activity, but as quantum lightning illuminating the vast networks of your mind faster than thought itself. There's another deep mystery that quantum consciousness theories address: the binding problem. Your conscious experience feels unified and coherent. Right now, you're simultaneously aware of my voice, perhaps the feeling of your clothes, the temperature of the room, your own thoughts and reactions. All of these separate inputs somehow combine into a single, unified conscious experience. But how? Your brain processes visual information in one region, auditory information in another, emotional responses in yet another. How do all these separate processes come together to create your unified sense of being a single conscious entity experiencing a coherent world? Classical neuroscience struggles with this question because classical systems can share information, but they can't truly unify in the way consciousness seems to require. Quantum mechanics, however, offers a solution through entanglement. When quantum systems become entangled, they form a unified whole that cannot be decomposed into separate parts. The measurement of one instantly affects the other, regardless of the distance between them. Could consciousness emerge from vast networks of quantum entanglement throughout your brain, creating a unified field of experience that spans across all your mental processes? This would mean that the unity of consciousness, the fact that you experience yourself as a single coherent being rather than a collection of separate mental processes, might be a direct reflection of quantum mechanical principles operating in your brain. As you sit there now, feeling yourself as a unified conscious being, consider that this sense of unity might be one of the most direct experiences you can have of quantum mechanics in action. Perhaps the most mind-bending aspect of quantum consciousness theories involves the role of observation in quantum mechanics. In quantum physics, the act of measurement doesn't just reveal a pre-existing state, it actually determines the outcome. The observer plays a fundamental role in shaping physical reality. This has led some researchers to wonder, if consciousness involves quantum processes, and if quantum processes require observation to determine outcomes, then what is doing the observing in consciousness? Are we witnessing a strange loop where consciousness observes its own quantum processes, creating a kind of self-referential system where mind and matter bootstrap each other into existence. It's a dizzying possibility that consciousness might not just emerge from quantum processes, but might be the very mechanism by which quantum possibilities collapse into the definite experiences of your mental life. This remains highly speculative, and I want to emphasize that this is far from scientifically proven, but it opens up profound questions about the relationship between mind and physical reality that go to the very heart of both quantum physics and consciousness studies. Some versions of quantum consciousness theory embrace what philosophers call panpsychism, the idea that consciousness, or at least proto-consciousness, is a fundamental feature of reality, present even at the level of elementary particles and quantum fields. According to this view, what we experience as human consciousness isn't something that suddenly appears in sufficiently complex brains, but rather a highly organized amplification of conscious properties that exist throughout nature at the quantum level. The microtubules in your neurons might serve as interfaces, connecting the large-scale classical activity of neural networks with the quantum-scale conscious processes that permeate reality at its most fundamental level. It's a breathtaking vision. Consciousness not as a late arrival in cosmic evolution, but as something woven into the very fabric of space-time itself, with your awareness representing a local flowering of a consciousness that extends throughout the universe. Now, before we continue deeper into this quantum landscape of consciousness, I want you to pause for a moment. Notice your own awareness right now. Notice the thoughts arising and passing away, the sensations in your body, the quality of your attention itself. According to the theories we're exploring, this very awareness might be connected to quantum processes occurring at scales so small they exist at the boundary between matter and geometry itself. It's a profound thought that your most intimate, subjective experience might be a window into the deepest levels of physical reality. What's truly remarkable is that if these theories are correct, then every moment of your waking life, your brain is conducting quantum experiments that would make the most sophisticated physics laboratories jealous. The microtubules we've been exploring aren't just scattered randomly through your neurons. They form vast interconnected networks that span across your entire brain, creating what could be described as a biological quantum internet. Think about the scale we're talking about here. Each neuron in your brain contains millions of tubulin proteins arranged in these billion neurons in your brain, wearotubule structures. With roughly 86, we're looking at quintillions of these quantum switches potentially working in concert. That's more in the observable universe. All contain quantum processing elements than there are stars within the space of your skull. But here's where it gets even more intriguing. Recent research has revealed that these microtubule networks don't operate in isolation. They're connected through gap junctions, tiny channels that allow direct communication between neurons, bypassing the usual synaptic transmission. This means that quantum information could potentially flow directly from neuron to neuron, creating brain-wide quantum networks that operate beneath the level of classical neural activity. Imagine, for a moment, that as you're processing these words right now, there might be quantum information cascading through networks that connect regions of your brain in ways that classical neuroscience has barely begun to map. Your understanding of this concept might be emerging not just from neurons firing in sequence, but from quantum coherence states that span across multiple brain regions simultaneously. There's another fascinating piece of this quantum puzzle that connects to something you can actually observe in your own experience: the rhythmic nature of consciousness itself. Have you ever noticed that your awareness seems to pulse or flicker? That there are tiny gaps in the stream of consciousness, moments where experience seems to refresh itself? This isn't just subjective impression. Neuroscientists have discovered that the brain operates in rhythmic cycles with different frequencies of brain waves corresponding to different states of consciousness. But according to quantum theories, these rhythms might reflect something far more fundamental than just neural oscillations. The Aucoin theory proposes that consciousness emerges in discrete moments, like frames in a film, each corresponding to a quantum collapse event in microtubule networks. These moments of conscious experience are predicted to occur roughly 40 times per second, fast enough that they seem continuous, but discrete enough that each moment represents a fresh quantum computation. It's a bit like watching a movie. You experience smooth motion and continuous action, but in reality, you're seeing a series of still frames projected in rapid succession. Could consciousness work the same way? Could each moment of your awareness be a quantum snapshot, a collapse of possibilities into the definite experience of now? As you listen to these words, try to tune into the rhythm of your own awareness. Notice how thoughts arise and pass away, how attention shifts and flows. According to these theories, each of these moments might correspond to quantum events happening at the most fundamental level of your brain's architecture. One of the strongest criticisms of quantum consciousness theories has always been the temperature problem. Quantum effects are notoriously fragile, easily disrupted by heat and environmental noise. The human brain operates at body temperature around 37 degrees Celsius, in an environment filled with thermal vibrations that should destroy quantum coherence almost instantly. For years, this seemed like an insurmountable obstacle. How could delicate quantum states survive in such a chaotic environment? It would be like trying to perform precision surgery during an earthquake. But nature, it turns out, is far more clever than we initially imagined. The discovery of quantum effects in photosynthesis revealed that biological systems have evolved sophisticated mechanisms to protect and even exploit quantum coherence at warm temperatures. Plants achieve nearly perfect energy transfer efficiency through quantum superposition, states that persist for surprisingly long times, even in the noisy environment of living cells. More recently, researchers have discovered that the specific environment inside microtubules might actually be conducive to quantum coherence. The hollow interior of these structures creates a relatively isolated space, protected from much of the thermal noise of the surrounding cell. The precise geometric arrangement of tubulin proteins creates what physicists call an ordered water environment, where water molecules arrange themselves in structured patterns that could help maintain quantum states. Even more intriguingly, some researchers have proposed that thermal energy, rather than being purely destructive to quantum effects, might actually power them. Just as a steam engine converts thermal energy into mechanical work, biological quantum systems might convert thermal energy into quantum computational power. This doesn't mean that quantum effects in the brain are proven, but it does mean that the temperature objection, once considered fatal to these theories, is far from decisive. The boundary between the quantum and classical worlds might be much more permeable than we once thought. Let's return to that fundamental question we started with. Why does consciousness feel like anything at all? Even if we accept that quantum processes occur in the brain, why should quantum collapse or quantum computation give rise to subjective experience rather than just more sophisticated information processing? This is where quantum consciousness theories offer something genuinely novel. In classical physics, all processes are, in principle, reducible to the motion of particles following deterministic laws. There's no room for anything genuinely new or creative to emerge. But quantum mechanics introduces something unprecedented, genuine indeterminacy at the fundamental level of reality. When a quantum system undergoes collapse, the outcome isn't determined by prior physical states. There's an irreducible element of novelty, of genuine creativity, built into the fabric of reality itself. Some interpretations of quantum consciousness suggest that subjective experience emerges from this creative aspect of quantum collapse, that consciousness is the inside view of quantum indeterminacy. Think of it this way. Perhaps consciousness doesn't arise despite the randomness of quantum mechanics, but because of it. The unpredictability, the genuine novelty, that quantum systems can generate might be precisely what gives rise to the felt quality of conscious experience. This is, of course, highly speculative, and there's no scientific consensus on this interpretation, but it offers a potential bridge between the objective world of physics and the subjective world of consciousness that no purely classical theory can provide. If consciousness does involve quantum processes, this raises fascinating questions about evolution. Why would natural selection favor the development of quantum coherence in neural systems? What evolutionary advantages could quantum consciousness provide? One possibility involves computational efficiency. Classical neural networks, for all their sophistication, face fundamental limits in terms of processing speed and energy consumption. Quantum computation, with its ability to process multiple possibilities simultaneously and perform certain calculations exponentially faster than classical computers, could provide significant evolutionary advantages. Consider the speed at which you can recognize a face, make a complex decision, or generate a creative insight. These processes happen far faster than classical neural networks should allow. If consciousness involves quantum computation, this could explain the remarkable efficiency of biological intelligence. There's also the question of creativity and insight. Classical computation, no matter how sophisticated, follows deterministic rules. It can process information and follow algorithms, but it's unclear how it could generate genuinely novel ideas. Quantum processes, with their inherent unpredictability and ability to explore multiple possibilities simultaneously, might provide the basis for creativity, intuition, and insight. The discovery that quantum networks in neurons can process information hundreds of millions of times faster than classical chemical processes suggests that evolution might have stumbled upon quantum advantages billions of years ago, long before humans learned to harness quantum mechanics in laboratories. Here's where things get truly mind-bending. In quantum mechanics, measurement plays a fundamental role in determining outcomes. A quantum system exists in superposition until it's measured, at which point it collapses into a definite state. But what constitutes a measurement? This question has puzzled physicists for nearly a century. Some interpretations suggest that consciousness plays a role in quantum measurement, that the act of conscious observation is what causes quantum collapse. While this interpretation is controversial and not widely accepted among physicists, it raises profound questions when combined with quantum theories of consciousness. If consciousness involves quantum processes, and if conscious observation plays a role in quantum measurement, then we might have a strange loop, consciousness emerging from quantum processes that are themselves influenced by conscious observation. It's a dizzying possibility that consciousness and physical reality might be locked in a kind of cosmic dance, each shaping the other in ways we're only beginning to understand. This remains highly speculative, and I want to emphasize that this is not a proven scientific fact, but it illustrates how quantum consciousness theories push us to reconsider fundamental questions about the relationship between mind and matter, observer and observed. If consciousness does involve quantum processes, this could revolutionize our approach to mental health and neurological disorders. Many conditions, from depression and anxiety to Alzheimer's disease and schizophrenia, might involve disruptions to quantum information processing in the brain. Traditional psychiatric medications work by altering neurotransmitter levels, affecting the chemical communication between neurons. But if consciousness depends on quantum processes in microtubules, then entirely new classes of treatments might be possible. Instead of just modifying chemical signals, we might be able to enhance or restore quantum coherence in neural networks. Some researchers are already exploring this possibility. Studies have shown that certain compounds can stabilize microtubule structures and potentially enhance quantum processes in neurons. Electromagnetic field therapy, already used experimentally for depression and other conditions, might work by influencing quantum states in brain tissue. The quantum theory of anesthesia suggests that understanding fewer side effects, quantum processes in consciousness, could lead to better anesthetic agents, which might also explain why some people are resistant to anesthesia or why consciousness sometimes returns unexpectedly during surgery. Even meditation and other contemplative practices might work in part by influencing quantum processes in the brain. The profound changes in consciousness reported by experienced meditators might reflect alterations in quantum coherence patterns that create new possibilities for awareness and insight. Of course, all of this remains speculative. We're still in the very early stages of understanding how quantum mechanics might relate to consciousness, let alone how to harness these processes therapeutically. But the possibilities are tantalizing, offering hope for entirely new approaches to understanding and treating disorders of consciousness. Perhaps the most awe-inspiring aspect of quantum consciousness theories is what they suggest about our place in the universe. If consciousness emerges from quantum processes, and if quantum mechanics governs the behavior of matter and energy throughout the cosmos, then consciousness might be far more fundamental and widespread than we ever imagined. Some versions of these theories embrace panpsychist ideas, suggesting that proto-conscious properties exist throughout nature, from the quantum level on up. According to this view, the microtubules in your neurons might serve as sophisticated interfaces, amplifying and organizing quantum conscious processes that permeate reality itself. This would mean that consciousness isn't a rare accident that occurred only on fundamental feature of the universe, Earth, after billions of years of evolution, but as basic as mass energy or electric charge. Your awareness might be connected to conscious processes occurring throughout the cosmos, from the quantum fluctuations of empty space to the vast structures of galaxies. It's a breathtaking vision that places consciousness at the very heart of reality. Instead of being isolated biological entities struggling for survival on a hostile planet, we might be local manifestations of a cosmic consciousness that extends throughout space and time. Now, as you sit there contemplating these ideas, take a moment to notice your own awareness. Feel the sense of being present, of experiencing this moment. According to the theories we've been exploring, this very experience of awareness might be your most direct contact with the fundamental quantum processes that shape reality itself. Whether or not these theories prove correct, they invite us to see consciousness not as a mere byproduct of brain chemistry, but as something profound and mysterious that connects us to the deepest levels of existence. They suggest that the questions, "What am I?" and "What is the universe?" might ultimately have the same answer. One of the most exciting aspects of quantum consciousness research is that it's moving beyond pure theory into testable science. The Orcoar theory makes specific predictions that can be experimentally verified or refuted, marking a crucial transition from philosophical speculation to empirical investigation. Researchers are now developing sophisticated techniques to directly measure quantum effects in living neural tissue. Using advanced spectroscopy methods, they can detect quantum coherence in microtubule networks and observe how these effects change under different conditions. The discovery of superradiance in tryptophan networks represents just the beginning of this experimental program. Perhaps most significantly, the relationship between anesthesia and consciousness provides a natural laboratory for testing quantum theories. If consciousness depends on quantum processes in microtubules, then anesthetics should specifically disrupt these processes. Early experiments support this prediction, showing that anesthetics do indeed affect quantum properties of neural molecules in ways that correlate with their ability to eliminate consciousness. Future experiments might involve using advanced imaging techniques to observe quantum processes in living brains, testing whether these processes are disrupted in unconscious states and restored when consciousness returns. Researchers are also exploring whether electromagnetic fields can influence quantum states in neural tissue, potentially providing non-invasive ways to study and even manipulate consciousness. The development of quantum computers might also provide insights into consciousness. If consciousness involves quantum information processing, then advances in artificial quantum systems might help us understand how biological quantum computers work, and perhaps even create artificial systems with genuine conscious experiences. As you absorb these possibilities, consider that we might be living through a pivotal moment in human understanding, when the mystery of consciousness finally begins to yield its secrets to scientific investigation. The questions that have puzzled philosophers and scientists for centuries might soon have empirical answers. The integration challenge. One of the ongoing challenges for quantum consciousness theories is explaining how quantum processes in individual neurons integrate to create unified conscious experiences. Even if quantum effects occur in microtubules, how do these microscopic quantum events combine across billions of neurons to produce the coherent, unified experience of consciousness? This is where the concept of quantum field effects becomes crucial. Rather than thinking of quantum processes as isolated events in individual microtubules, researchers propose that quantum coherence might extend across entire brain regions through quantum field interactions. Just as electromagnetic fields can influence charged particles across vast distances, quantum consciousness fields might coordinate neural activity in ways that classical neuroscience has yet to discover. The gap junctions that connect neurons directly, bypassing normal synaptic transmission, might serve as quantum channels, allowing coherent quantum states to spread throughout neural networks. This could create what physicists call macroscopic quantum coherence, where quantum effects persist at scales large enough to influence neural computation and conscious experience. Recent discoveries in quantum biology suggest that such large-scale quantum effects are not only possible, but might be common in biological systems. The quantum coherence observed in photosynthesis, for example, extends across molecular networks large enough to be visible under microscopes. If evolution has produced quantum coherence at such scales in plants, it's not unreasonable to imagine similar or even more sophisticated quantum effects in the complex networks of the human brain. This integration of quantum effects across neural networks might explain not just the unity of consciousness, but also its remarkable flexibility and creativity. Classical neural networks, while sophisticated, are limited by their deterministic nature. Quantum neural networks could explore multiple possibilities simultaneously, generate genuinely novel solutions, and integrate information in ways that transcend classical computational limits. As your mind processes these ideas right now, integrating concepts from quantum physics, neuroscience, and consciousness studies into a coherent understanding, you might be witnessing this very process of quantum-enhanced neural integration in action. The speed and creativity with which you can connect these disparate concepts might reflect quantum computational processes that operate beneath the threshold of conscious awareness. This remains speculative, and there's no scientific consensus that individual thoughts or mental processes directly influence quantum events. But the possibility that consciousness emerges from quantum integration processes offers a tantalizing glimpse into how the unified field of awareness might arise from the quantum substrate of neural activity. As we venture deeper into this quantum landscape of consciousness, we encounter one of the most perplexing paradoxes in all of science. It's a puzzle that sits at the intersection of physics and philosophy, challenging our most basic assumptions about the nature of reality itself. Consider this: every scientific observation of quantum consciousness theories requires conscious observers to conduct the experiments. We use our conscious minds to design studies, interpret data, and draw conclusions about the very consciousness we're trying to understand. It's like trying to see your own eyes without a mirror, or attempting to bite your own teeth. This creates what philosophers call a strange loop. If consciousness emerges from quantum processes, and if understanding these processes requires conscious observation, then we're trapped in a recursive puzzle where the thing being studied is also the thing doing the studying. Take a moment to feel this paradox in your own experience. Right now, you're using your consciousness to contemplate consciousness itself. Your awareness is turned upon itself like a snake eating its own tail. There's something both humbling and profound about this recursive nature of conscious self-examination. Some interpretations suggest that this isn't just a methodological problem, but a fundamental feature of reality. Perhaps consciousness and quantum mechanics are so intimately connected that you cannot fully understand one without the other. The observer and the observed might be more deeply intertwined than classical physics ever imagined. The information integration revolution. While quantum theories offer one approach to understanding consciousness, another revolutionary framework has emerged from a completely different direction. Integrated information theory, developed by neuroscientist Giulio Tononi, proposes that consciousness corresponds to integrated information that exists as a unified whole, rather than as separate parts. According to this theory, consciousness isn't just about processing information, it's about integrating information in such a way that the whole becomes greater than the sum of its parts. Imagine the difference between a pile of puzzle pieces and a completed puzzle. The individual pieces contain information, but the integrated picture reveals something that exists nowhere in the separate parts. What makes this particularly fascinating is how it might connect to quantum mechanics. Recent research has begun exploring how quantum entanglement could create the kind of information integration that IIT proposes is necessary for consciousness. When quantum systems become entangled, they form unified wholes that cannot be decomposed into separate parts, exactly the kind of integration that this theory suggests underlies conscious experience. This quantum extension of information integration theory offers a different perspective from the microtubule theories we've been exploring. Instead of focusing on specific quantum processes in particular cellular structures, it suggests that consciousness emerges from patterns of quantum information integration that could occur across various scales and systems throughout the brain. As you process these words right now, notice how separate concepts, quantum mechanics, information theory, neuroscience, somehow integrate in your understanding to form coherent ideas. This very process of intellectual integration might reflect the quantum information integration that some theories propose underlies all conscious experience, the measurement problem revisited. The relationship between consciousness and quantum measurement remains one of the most contentious areas in both physics and consciousness studies. While most physicists reject the idea that conscious observation is necessary for quantum collapse, the connection continues to provoke fascinating questions about the nature of both consciousness and physical reality. Here's where things get particularly intriguing. Some interpretations suggest that rather than consciousness causing quantum collapse, both consciousness and quantum measurement might emerge from the same underlying processes. Perhaps what we call measurement in physics and what we call observation in consciousness are different aspects of a more fundamental phenomenon that operates at the intersection of mind and matter. This doesn't mean that your thoughts directly influence quantum events, a claim that lacks scientific support. Rather, it suggests that the processes by which quantum possibilities become definite outcomes might share deep structural similarities with the processes by which conscious experiences emerge from neural activity. Consider the moment when you suddenly understand a complex idea or recognize a familiar face. There's a sense in which multiple possibilities collapse into a single, definite recognition. While this is metaphorical rather than literal quantum collapse, it illustrates how the language and concepts of quantum mechanics might provide useful frameworks for understanding consciousness, even if the connection isn't direct or causal. The ongoing research into quantum measurement theory continues to reveal new subtleties about how quantum systems interact with their environments. As we develop more sophisticated understanding of measurement processes, we might also gain new insights into the processes that underlie conscious observation and recognition. One of the most compelling aspects of recent neuroscience research involves the discovery of vast networks that operate across different scales simultaneously. Your brain isn't just a collection of individual neurons, it's a hierarchy of interconnected networks, from molecular networks within cells to neural networks spanning entire brain regions. If quantum processes do play a role in consciousness, they would likely operate within this multi-scale network architecture. Quantum effects in microtubules might influence local neural processing, which in turn affects network-level activity, which ultimately shapes global brain dynamics and conscious experience. This multi-scale integration poses fascinating questions about how quantum and classical processes might interact. Perhaps consciousness emerges not from purely quantum processes or purely classical processes, but from the complex interplay between quantum effects at cellular scales and classical network dynamics at larger scales. Recent advances in network neuroscience have revealed that the brain exhibits what scientists call small world properties, where local clustering combines with long-range connections to create networks that are both specialized and integrated. These network properties might be precisely what's needed to amplify microscopic quantum effects into macroscopic conscious experiences. As you listen to these ideas, your brain is orchestrating activity across millions of neurons organized into countless overlapping networks. The fact that you can follow this complex discussion while simultaneously maintaining awareness of your body, your environment, and your own thoughts demonstrates the remarkable integration capabilities of neural networks operating at multiple scales. Whether or not quantum effects contribute to this integration, the sheer complexity and sophistication of brain networks provides a humbling reminder of how much we still don't understand about the biological basis of consciousness. If consciousness does involve quantum processes, when did these capabilities evolve? Did quantum consciousness emerge suddenly with complex brains, or has it been developing gradually over millions of years of evolution? Some researchers speculate that quantum effects in biological systems might be ancient, perhaps dating back to the earliest life forms. The quantum coherence observed in photosynthesis suggests that life discovered quantum mechanical advantages very early in evolutionary history. If quantum processes provide computational benefits, natural selection would have had billions of years to refine and optimize these capabilities. This raises intriguing questions about consciousness in other species. If quantum effects contribute to human consciousness, do they also operate in the brains of other animals? The discovery of quantum navigation in birds and quantum effects in plant photosynthesis suggests that quantum biology is widespread throughout the natural world. Perhaps consciousness isn't unique to humans or even to complex brains, but represents a spectrum of quantum information processing capabilities that exists throughout the biological world. Your own consciousness might be the result of quantum processes that have been refined through billions of years of evolution, connecting you to an ancient lineage of quantum-enhanced life. This perspective invites a sense of kinship with the natural world. The quantum effects that might underlie your thoughts and experiences could be variations on themes that play out in forests, oceans, and ecosystems around the globe. Consciousness, rather than separating you from nature, might be one of the most profound ways you're connected to it. As quantum computing technology advances, we're beginning to see intriguing parallels between artificial quantum systems and the hypothetical quantum processes that might occur in biological consciousness. both involve maintaining quantum coherence in noisy environments. Both face challenges from decoherence, and both might require sophisticated error correction mechanisms. The development of room temperature quantum computers could provide new insights into how biological systems might maintain quantum coherence. If engineers can create artificial quantum systems that operate in warm, noisy environments, it becomes more plausible that evolution could have produced similar capabilities in biological systems. Some researchers are exploring hybrid classical quantum AI architectures that might more closely resemble how consciousness could emerge from the interaction between classical neural networks and quantum processes. These systems could potentially exhibit capabilities that neither classical nor purely quantum systems could achieve alone. While we're still far from creating artificial consciousness, the convergence of quantum computing and neuroscience might eventually lead to artificial systems that exhibit some of the integrative, creative, and intuitive capabilities that characterize biological consciousness. As you contemplate these possibilities, consider that the device you might be listening on represents the cutting edge of classical computation, processing information through billions of transistor switches. Yet if quantum consciousness theories are correct, your brain might be operating on principles that transcend anything our current technology can achieve. The potential medical applications of quantum consciousness research extend far beyond treating neurological disorders. If consciousness involves quantum information processing, then practices that influence conscious states might also affect quantum processes in the brain. Meditation, for example, produces measurable changes in brain activity and structure. While there's no proven connection to quantum effects, some researchers speculate that contemplative practices might influence quantum coherence patterns in neural networks. The profound changes in awareness reported by experienced meditators could reflect alterations in quantum information processing that create new possibilities for consciousness. Other practices like yoga, breathwork, and various forms of therapy that affect conscious states might also influence quantum processes, though this remains highly speculative and unproven. The point isn't that these practices directly manipulate quantum mechanics, but that understanding the quantum dimensions of consciousness might provide new frameworks for understanding how consciousness can be cultivated and transformed. The placebo effect, where belief and expectation can produce real physiological changes, might also reflect quantum aspects of consciousness. While the mechanisms remain mysterious, the fact that conscious states can influence physical health suggests deep connections between mind and matter that quantum theories of consciousness might help illuminate. Take a breath and notice your own state of consciousness right now. Feel the quality of your attention, the clarity or cloudiness of your thoughts, the sense of presence or distraction. According to speculative interpretations of quantum consciousness theories, these subjective qualities of awareness might correspond to different patterns of quantum information processing in your brain. One of the deepest puzzles in consciousness research involves what's called the combination problem. How do separate conscious experiences combine into unified consciousness? If individual neurons or even individual quantum processes have some form of proto-conscious properties, how do they integrate into the unified field of awareness that characterizes your conscious experience? Classical physics struggles with this problem because classical systems remain fundamentally separate even when they interact. But quantum mechanics offers new possibilities. Through entanglement and superposition, quantum systems can form unified wholes that cannot be decomposed into separate parts, potentially providing a mechanism for the integration that consciousness seems to require. This doesn't solve the combination problem completely, and there's no scientific consensus that quantum entanglement directly creates unified consciousness. But it offers new conceptual tools for thinking about how separate processes might combine into integrated experiences. The challenge remains formidable. How do we get from quantum processes in microtubules to the rich, unified, conscious experience you're having right now. This explanatory gap persists, even in quantum theories of consciousness, reminding us that we're still in the early stages of understanding how consciousness emerges from physical processes. As you experience the unified flow of these ideas, notice how separate concepts somehow combine in your awareness to form coherent understanding. This integration of information into unified conscious experience remains one of the deepest mysteries in science, whether we invoke quantum mechanics or not. Quantum consciousness theories don't just change our understanding of the brain, they potentially transform our entire worldview. If consciousness emerges from quantum processes that connect to the fundamental structure of reality, then mind and matter might be more intimately related than Western philosophy has traditionally assumed. This connects to ancient philosophical traditions that have long proposed intimate relationships between consciousness and the natural world. While we must be careful not to read modern physics into ancient wisdom traditions, there are intriguing resonances between quantum mechanical concepts and contemplative insights about the nature of mind and reality. The implications extend to questions of free will, personal identity, and the nature of self. If consciousness involves quantum indeterminacy, then perhaps there's genuine creativity and novelty built into the fabric of awareness itself. Your choices and decisions might reflect quantum processes that introduce genuine unpredictability into the causal order. This remains highly speculative, and there's no scientific consensus that quantum mechanics provides the basis for free will. But these theories invite us to reconsider fundamental questions about agency, responsibility, and the nature of human choice. The relationship between individual consciousness and cosmic consciousness also takes on new dimensions in quantum theories. If consciousness connects to quantum processes that operate throughout nature, then perhaps individual awareness is more continuous with universal processes than we typically imagine. As we look toward the future of consciousness research, quantum theories represent just one approach among many promising avenues of investigation. Whether or not consciousness ultimately proves to involve quantum mechanics, these theories have already contributed valuable insights and new experimental approaches to understanding the mind. The development of new technologies for measuring quantum effects in biological systems will likely provide definitive tests of quantum consciousness theories within the coming decades. Advanced brain imaging techniques, quantum sensors, and sophisticated computational models will help determine whether quantum processes play genuine roles in neural function and conscious experience. Even if quantum effects prove irrelevant to consciousness, the interdisciplinary collaboration between physicists, neuroscientists, and philosophers that these theories have fostered represents a valuable contribution to consciousness research. The questions they raise about the relationship between mind and matter will continue to drive scientific inquiry regardless of how the quantum debate resolves. As you sit there now, contemplating these possibilities, you're participating in one of the most profound intellectual adventures in human history. The attempt to understand consciousness scientifically represents our species' effort to comprehend its own nature through the methods of empirical inquiry. Whether consciousness emerges from quantum processes, classical neural networks, or something else entirely, the fact that matter can organize itself into systems capable of self-awareness remains one of the most remarkable phenomena in the known universe. You are a walking example of the universe becoming conscious of itself. Perhaps the most important lesson from exploring quantum consciousness theories isn't any particular answer they might provide, but the sense of wonder they evoke about the mystery of consciousness itself. These theories remind us that consciousness remains largely unexplained, that the familiar experience of being aware harbors depths we've barely begun to fathom. There's something beautiful about living with these profound questions still unanswered. The mystery of consciousness connects you to the frontier of human knowledge, to the edge where science meets philosophy and empirical investigation encounters the deepest puzzles about existence itself. As you go about your daily life, carrying this awareness of consciousness as mystery, you might find that ordinary experiences take on new dimensions. The simple fact of being aware, of experiencing colours and sounds and thoughts and feelings, becomes not just a background condition, but a source of ongoing wonder. The quantum theories we've explored might prove correct, or they might be replaced by entirely different frameworks. But the questions they raise about the nature of mind, matter, and their relationship will likely persist as long as conscious beings continue to investigate the nature of their own existence. In the end, perhaps the greatest insight from quantum consciousness research isn't about quantum mechanics at all, but about the profound mystery of consciousness itself. You are not just a biological machine processing information, you are awareness itself, temporarily organized into human form, capable of contemplating the very processes that might underlie your own existence. That capacity for self-reflection, that ability to turn consciousness upon itself in wonder and investigation, might be the most remarkable quantum phenomenon of all, regardless of whether it literally involves quantum mechanics or not. As we reach the end of this journey into the quantum depths of consciousness, take a moment to simply breathe and notice what's happening in your awareness right now. The very fact that you can reflect on these ideas, that you can turn consciousness upon itself and contemplate its own mystery, might be the most extraordinary phenomenon we've encountered today. Whether consciousness emerges from quantum processes, dancing in microtubules, classical neural networks, weaving information into experience, or something else entirely that we haven't yet imagined, one thing remains beautifully certain. You are not just matter in motion. You are awareness itself, temporarily organized into human form, capable of pondering the deepest questions about existence. These quantum theories of consciousness remain speculative, unproven by scientific consensus, yet they've opened doorways to wonder that might never have existed otherwise. They've reminded us that consciousness, this most intimate aspect of our existence, still holds secrets that science is only beginning to approach. Perhaps that's exactly as it should be. Some mysteries are worth living with, worth carrying as sources of ongoing awe rather than puzzles to be definitively solved. The quantum nature of reality, the hard problem of consciousness, the relationship between mind and matter. These questions connect you to the very frontier of human understanding. As you move through your days ahead, carrying this sense of consciousness as mystery, remember that every moment of awareness is a small miracle worthy of wonder. Until we meet again, in the quiet spaces where science and mystery dance together, keep questioning, keep marveling, and keep listening to the whispers of your own mysterious mind.